Hey guys, and welcome back. Now, one of the most important concepts to understand within a Linux system, and certainly for the LPIC 1 examination, is to understand the Linux boot process. So what exactly is the Linux boot process? What does it do for us? Well, quite simply, it's how the system is going to boot so that we can operate it. Because when you think about it, when you turn on your machine, there has to be a whole series of different processes that effectively build upon each other so that we eventually get to our fully functioning Linux system, in our case, our desktop. But it's not enough for us to just say, we push on the power button and our Linux machine boots up. That is not going to give enough detail to pass the questions on the LPIC 1 examination. So what we're going to have to do within this nugget right here is to walk through every single process step by step and to pick out the relevant details that we have to understand. So how about we walk through it then, shall we? Now, the very first thing that we have to understand is something called the BIOS. Now, what the BIOS stands for, it stands for the Basic Input-Output System, BIOS. Now, when we push the power button on our laptop or on our desktop computer, the BIOS is going to perform what is called a post. This is a power on self-test. This is ultimately just an integrity check to just ensure some basic functionality is operational. So ultimately, the power on self-test is going to test things like hardware operability. So things like your hard drive, that might be a solid state drive, things like your keyboard, and maybe a little test of the RAM. Now, a key thing to remember is that the BIOS runs from ROM, read-only memory. And this effectively comes from the motherboard of your computer. Now, the key thing to note here is that this BIOS part, this is actually completely independent of the operating system. So basically what I'm saying here is that this part here, it doesn't matter if you're going to be booting a Linux operating system or a Windows operating system. This is going to happen automatically based on the hardware within your actual computer itself. So it is independent of the operating system itself. Now, the other thing that the BIOS is going to be used for is actually to boot the operating system. And this is ultimately what is going to determine what operating system is going to be running on your computer. So let me just quickly show you what a BIOS screen might look like. So if you happen to do a search for BIOS screen and you click one of these links right here, let's say this one right here, let's open this up. This is ultimately an example of a BIOS screen. And we can see here we have many different options. One of those options is this boot menu. And in the case here, this is the boot order that BIOS is going to work through. Now at the very top we can see here we have a CD-ROM drive, we also have removable devices, these could be USB sticks, and we have a hard drive as well as a network boot. Now ultimately you can change the order of this menu, meaning that whatever you put at the top, that is going to take priority. But essentially what BIOS is going to do, it's going to run through these different options, and it's going to be looking for something called an MBR. This is a master boot record. So ultimately, the BIOS will check, in this case here, the CD-ROM drive. Does this have an MBR? If it does, then it's going to attempt to load the operating system from the CD-ROM drive. If it doesn't find that though, well, it'll go to the next option, the removable devices. Again, it's going to check for the presence of an MBR to attempt to boot an operating system. And then again, if there is not one found, it can go to the hard drive, so on and so forth. Again, checking for the master boot record. So what is so special about this master boot record then? Well, here is the thing. When the MBR is run, the bootloader then begins to start. Now, it's important to understand for the purposes of the examination that the MBR is located on the very first sector of the drive. And this MBR, it really is quite tiny. The MBR is only 512 bytes. Notice this is not gigabytes or megabytes, this is just 512 bytes. It's just a very small piece of information that's going to contain the bootloader program itself, as well as disk partitioning information. So like I say, the MBR provides us information relating to the bootloader. Now historically, Linux used to have a bootloader called Lilo or Lilo. however you prefer to say it. This was effectively known as the Linux loader, which is where the name comes from, Lilo. Now the other option, which is the more modern option, is one called Grub. This is known as the Grand Unified Bootloader. Now one of the main differences between Grub and Lilo is that Lilo can only boot Linux-based operating systems, whereas Grub can be used for various operating systems such as Linux or even Windows, for example. And again, important piece of information, when it comes to the default bootloader for the modern operating systems, Grub is going to be the one you're going to be using. So kind of conceptualize that Lilo is out there, but it has really been replaced by Grub. Now when you are actually utilizing Grub, very often this is going to be the very first thing you see as a splash screen. So you'll see a simple menu pop up where you can select some different types of options, whereby you can perhaps choose different kernel images that you may have installed. And in fact, it's more accurate to say that modern Linux systems actually use Grub 2, which is a more modern implementation of the Grub system. A key thing to note here is that the Grub system is going to run in RAM. This is random access memory. So if you ever happen to have what is called a dual boot system, whereby you have two different operating systems installed, say for example you may have a Windows system, as well as on the same machine maybe a copy of Ubuntu, when the Grub menu loads up, you can actually choose which system do you want to boot up. Do you want to boot up the Windows and log into Windows, or do you want to boot up Ubuntu and use Ubuntu? But ultimately, the main purpose of Grub, the main objective here, is to load our kernel into memory. And once we have done this, we come to the next stage, which is known as the kernel initialization stage. Now, we briefly touched upon what a kernel is within a previous skill within this very course, and we learned that the kernel is basically the core of the operating system, and this really is what makes a Linux device a Linux device. We are using the Linux kernel, and that kernel has total control over your operating system. So once we have reached the kernel initialization stage of the boot process, this is the kernel that was selected by Grub, and this is what is specified within the grub.conf file. Now, it is important to understand that before this actually happens, is that the kernel itself may actually be compressed. And in fact, this is actually the more common way you will find the kernel. So if the kernel is compressed, the bootloader is going to find this within boot.vm linux, and that is with a Z. If you see that Z at the end, that tells you we're dealing with a compressed kernel. Whereas if instead it is just VM Linux with an X, this tells you that it is uncompressed. But like I say, the more common version is to have that compressed kernel. Now finally, the kernel is going to load something in modern systems which is called systemd. Now, like I say, this is to deal with modern systems, and we'll get to see within this skills the other variants of this, but just understand that before systemd we had something called sysvinit. We'll get to look at that within the very next nugget. But like I say, systemd is the more modern version, and what systemd is going to do, this is going to handle all of the other Linux processes, as well as mounting the file systems. Now, like I say, we'll get to look at systemd as well as sysvinit, as well as another variant called upstart within this very skill. But ultimately, despite these variations, these are the main operations that the system is going to go through during the boot process. So I know that was a ton of information to go through, especially if this is the very first time you're hearing this information. So let's just briefly recap what we just learned. The very first thing we have is going to be the BIOS, the basic input-output system. This is going to execute the MBR, which is the master boot record. The master boot record is going to effectively invoke the bootloader, that can be Lilo, but in much more modern iterations that is going to be Grub, or Grub2 if you like. Grub is ultimately going to execute the kernel, and then we're going to load into modern instances something called systemd. And systemd is the mother of all the Linux processes, and it can handle the starting and stopping of services, whether you're running an Apache web server, you want to start it or you want to stop it. Everything here can be done via systemd. But in order to get from systemd, we have to walk through all of these different types of processes. Now, like I say, systemd is the modern system and service manager for Linux operating systems. But before that, we had something called sysvinit. Now, as it transpires, because we are dealing with the LPIC 1 examination, it's not enough to just say, hey, well, I'm just going to use systemd-based systems and forget about the old stuff like sysvinit. Wouldn't that make our life much, much easier? But the reality is, in order to pass the examination, we actually have to understand some key details about sysvinit. So what exactly do we have to know about sysvinit? Well, that's what we're going to be talking about in the very next nugget. So I hope this has been informative for you, and I'd like to thank you for viewing.